Hello, and welcome to Math with Mr. Bill. I'm Bill Anderson, and today we're going to be looking at a series of problems from calculus, several integration and integration application problems. So the first one today we're going to be looking at is a fairly typical integration problem. It's going to involve some u-substitution and then an evaluation. So we're asked to integrate here from 1 to 4 the product 3x squared plus 1 times the square root of 2x cubed plus 2x. So when I look at this first, the thing about integration is that everything's an art, right? There are a few things that you can use as a structure for integration, but oftentimes it's just a matter of looking at the integral and going, well, I think this is going to work. Try it. If it works, great. If it doesn't, you have to try another technique. But the first thing I notice here when I look at this integral is that outside here I have this 3x squared plus 1. And on the inside of the radical I have an expression that is 1 power higher in both terms than the one on the outside. So that tells me that the radicand, what's underneath the radical, should probably be what I'm going to use in my u substitution. And let's see if this works. So I let u equal 2x cubed plus 2x, and then du is equal to 6x squared plus 2 dx. Okay, so that's nice. We've got something with a squared term and then plus a constant, and what's even better is that this term, this expression here, 6x squared plus 2, is double 3x squared plus 1. So if I pull out the 2 out of that, then I get 3x squared plus 1 dx. And depending on how you want to proceed from here, I can solve for dx and do a substitution. I can find du in there or find 3x squared plus 1 dx in there. There's all kinds of things to do. I think for this, I'm going to go ahead and do a substitution. So I'm going to solve this for dx, and then I'll do my replacement here in a little bit. So du over 2 times 3x squared plus 1, and that's going to equal dx. Now the other thing I'd like to do is do a limits substitution. So I know that when x is equal to 4, then u is going to equal 2 times 4 cubed plus 2 times 4. And you might have to get your calculator for that, but that turns out to be 136. And when x is equal to 1, u is going to be equal to 2 times 1 cubed plus 2 times 1, which is 4. Okay, so now I'm ready to begin my substitutions. So let me rewrite this here. So going from 1 to 4 of 3x squared plus 1. All times the square root of 2x cubed plus 2x dx. Okay, let's do our substitution. So we've got our integral now. Now instead of 1 to 4, we're going from 4 to 136. We don't have anything to replace the 3x squared plus 1 just yet, but then we have the square root of u. And then dx we're going to replace with du over 2 times 3x squared plus 1. So there's our 3x squared plus 1 that we're going to be able to use to cancel this term right here. That's factor right there. Okay, so then let's see what I've got left over now. So now I've got the integral from 4 to 136. And then I've got the square root of u, and then times du over 2. So I want to make a couple of cosmetic changes here. I'm going to bring the 1/2 out front, and then I'm going to change the square root to the power of 1/2. So this becomes 1/2 times the integral of u to the 1/2. Forgot the limits here. 4 to 136. And then du. So now it's just a straight integration. So this becomes now 1/2 times the integral of u to the 1/2. So we add 1 to the exponent. So 1/2 plus 1 is 1/2 plus 2/2, which is 3/2. And then we flip that exponent and we put it out front. So there's our integration. And then we've got our limits of integration going from 4 to 136. So we'll do that evaluation. And we get the 1/2 and the 2/3, those can combine. So I'm going to put that on the outside right now. And then we get the top plugged into u. So that's 136 to the 3/2 minus the bottom plugged into u. So 4 to the 3/2. Now there's no perfect square root of 136, so we can leave it like that. We can make it look a little nicer using a radical. And then 4 to the 3/2, well, that's the square root of 4 cubed. So that's 2 cubed, which is 8. So I could clean this up a little bit, make this 1/3 times the square root of 136 cubed minus 8. And you could keep going a little bit more if you wanted to. There's all kinds of ways to finish that off. But that's it. That's the solution. So hope that made sense. And I will see you in the next video. Thanks.